Welcome everybody. I hope you guys are really enjoying the conference so far. With the new format, it's probably a lot different for a lot of people, and hopefully it's working out well for you. So yeah, like Meg said, if you have any questions throughout the presentation, just throw them in the chat box, and we're going to get to them right at the end. So this session, or I guess myself, my name is Nolan. I work for Sarcan Recycling, and I'm going to be the moderator today. And we have some really great presenters. We have three, and this session is robotics. And I think we can all agree that technology and software is being integrated into industries around the globe to solve unique and interesting problems and challenges that those industries are facing in unique and innovative ways. And we have three really great presenters today to talk about exactly that. We have Jared Fedorchuk, Matthew Smith, and Sam Dietrich joining us today, and they're going to be sharing their expertise with us on robotics, AI, and those. Excuse me. It's not COVID. I feel like you have to address every time that you cough or sniffle or sneeze or anything. It's just a little bit of allergies and talking. So yeah, without any further ado, let's get into it. This session is brought to you by Mterra Environmental. They are innovative thinkers trying to transform waste into resources, and they have sponsored this session, so thank you very much, Mterra. First up, we have Jared Fedorchuk. He has worked in the technology industry for nearly 20 years, and his passion for exploring and the leading edge of technology has never diminished. Though he started out his education in IT, Jared has since bet the farm on custom-built web-based frameworks with nearly unlimited potential for building business management software. And I think in the past little while with COVID and working from home, everybody can agree that that is a great solution. Recently, Jared co-founded Levis Media in order to take this web framework to the world. After 10 years in development, Levis Prism has become the backbone of a diverse range of cloud-based business tools, from website CMS to custom software as a service products. And it continues to expand. So thank you very much for joining us. Take it away, Jared.
Thank you, Nolan. I will just share my screen here and get started. Everyone can see that fine? Oh, wait, there we go. Everyone can see my screen? Great, okay. So thanks again for the introduction. Yes, my name is Jared Fedorchuk, and I am the president of Levis Tech. Some people call us Levis Media because that's what we started off with. Some people call us Levi's. I don't really care. As long as you know who we are in some regards, I'm pretty happy with that. So today for the presentation, I'll do a brief introduction on Levis Tech so you guys know a little bit more about us. I'm going to chat a little bit about, very briefly, a little history lesson on past innovations in the Industrial Revolution. Quick little primer on artificial intelligence and machine learning and exactly what it is in layman's terms for people that are unfamiliar with it. And we'll talk a little bit about how these new technologies can integrate with things that are already being done in your industries and in my industry as well. So as Nolan said, Levis Tech, we do web applications, and it's all based on a framework that I started about a decade ago or so called Levis Prism. It's a framework which means that we can build web applications very quickly and easily on it. And these are a list of the services that we do. We're software consultants. We have ERP software modules for a wide variety of industries. We do websites and applications, database, and custom software, and mobile applications as well. Okay. So a little bit about why AI is more important, or it's going to be a lot different than past technologies and innovations. It seems like human technology is really starting to grow exponentially. The amount of time that it takes for new products, new solutions to come out is really starting to decrease. Besides that, AI is very unique in that this technology can kind of build upon itself and build solutions for itself. So if we look at steam engines, like we use them to produce textiles, when we created electricity, that opened up a lot of other doors for automation. The third industrial revolution was getting to be quite unique as well, because it started to become so vast and so global in the way that we would communicate with technology and the internet and personal computers. The fourth industrial revolution is what we're experiencing right now, is based on AI, and it's going to be very disruptive. It will make a lot of jobs obsolete over the next couple decades. Government and businesses alike have been struggling to keep up with it, but we've really opened up Pandora's box already. There's no putting it back in. So it's really up to us to understand this technology and maximize it to the best of our ability, and know how to benefit ourselves from it. So what is artificial intelligence? Well, artificial intelligence, in short, is using computers to solve problems that are a little bit more abstract, that generally require human intelligence. So think about speech recognition, really advanced decision making, especially decision making where it's not always black and white, where there's a bit more of a gray zone. Computer vision, huge data insights and automation. These are the sorts of things that we're trying to solve with artificial intelligence. Machine learning is a much more specific subset of artificial intelligence. It's really taking a lot of data and statistical algorithms to help machines make decisions for us. If you're interested in tinkering around with it or knowing how accessible it is, there's a lot of platforms out there already catering to it. So at this point in time, it isn't like you have to write a lot of code from scratch. If you're a developer, there's a lot of platforms like Amazon and Google and Microsoft that you can use to integrate with your existing solutions. But even for people that aren't as technically inclined, there's a lot of ways that AI is being integrated in the tools that we use more and more often. Machine learning and artificial intelligence is also unique, and although we have a lot of fields of study on how we progress it and how we implement it and how we develop it, we actually don't really understand the inner workings of what's going on behind this technology. Long story short of how we create different types of AI and machine learning models are we create little bots and we create little programs that we train and train again using a lot of data and a lot of repetition, and eventually they're able to produce the desired outcomes for us. But if you're to look back at the logic level and the circuit level of what these look like, it really does become a bit of a soup. I guess you could say in some regards it would mimic the human brain, where you can see where things are kind of firing in general areas, but when you break it down to neurons, it's getting a little too complicated and a little bit out of human understanding. But that being said, we do have the science on how we can create these tools and create these methods. So machine learning is really not for massive companies anymore. It is coming into the hands of smaller businesses and individuals, and it does cater to a lot of different industries. We can use it to predict trends. We can use it in marketing. A lot of virtual agents and help desks that are available now, they are using AI and machine learning tools to engage with their clientele. If you engage in LinkedIn a lot, there are a lot of bots that are out there trying to talk to you and sell their services to you. At Levis, we use it a lot for production automation, so we'll touch a little bit on some of the things that we've done there. It can be used for natural language processing, so language translation, and computer vision as well. In regards to waste management, some of the cool things that are coming out, you have intelligent trash cans and waste sorting, waste reduction. This is probably one of the bigger fields that's going to dominate on artificial intelligence and machine learning over the next while. The United Nations have said that around 1.3 billion tons of food is wasted globally every year. That's enough to feed the world's 815 million hungry people 4 times over. So wastage is obviously a huge concern. A lot of that comes down to increased efficiency in supply chains, which of course boils down a little more to the market conditions around those supply chains. So if there's environmental variables, weather, transportation costs, all of these things can be factored in, and artificial intelligence and machine learning can help make our decisions for us. So one interesting case study regarding waste management. So 5 students from the Columbia Business School, they worked with gooduncle.com over the course of a semester, and they saved them about $30,000 in overage. So what Good Uncle does, they are a foods wholesaler. So restaurants and grocery stores could buy their foods from Good Uncle. So, and Good Uncle, of course, they need to get their goods to their customers very, very quickly. That's their whole business model. So in order to do this, they have to make sure they have enough goods on hand to roll out to whenever their clients need it. Now, the problem with this is it's really difficult to predict when the industry is going to demand a whole bunch of tomatoes, or when a new kind of bread is going to be the next big thing in stock. So Good Uncle partnered with these 5 students, and using machine learning and AI algorithms, they managed to forecast what goods they need to have on hand. And over the course of just one semester with a student group, they managed to reduce their overage by $30,000. So there's a lot of opportunity for some pretty substantial cost savings through implementing AI and ML into your business model. A couple other intriguing ideas that have come out in automation, and I know one of our fellow panelists is going to dig into this a lot more than I am, but just to scratch the surface, at the Vancouver airport, for example, they have a garbage can named Oscar, and pretty much you hold your garbage, you hold your bottle, whatever it is, in front of a camera, and it'll detect it, and it'll tell you which waste bin to put it in. Another company called Bin E, they've taken it a step further, and you can throw the waste directly into the bin, and it will actually sort it for you. So these are things that are out and about and in the market right now that are in waste management that are obviously, they wouldn't be possible without artificial intelligence and machine learning. So Levis's first foray into artificial intelligence and machine learning has really come at demand of our clients. Everything that we've done has been web-based, but as our clients' needs and expectations have grown, it's gotten to the point where we haven't really been able to satisfy our clients' needs using just the Levis Prism framework. It's great at what it does, which is building web applications, but we have to make it smarter to solve more abstract problems for our clients. So this is something that we developed in-house. We didn't partner with anyone on it, but we created a capture breaker. So I'm sure you guys have seen all these annoying characters and letters floating around whenever you try to log into some sort of website or portal. Well, one of our clients needed to get information from a bunch of other websites, and the websites gave us permission to log in and take all their information. However, they weren't willing to give us direct access. We just had to use whatever methods were at our disposal. So we created something, it's called a capture breaker. It's based on a subvector machine. Without boring you, pretty much what we had to do is we downloaded a lot of samples of this. We had to parse out all the letters. We fed it to our AI program, and when we connected it to our software is easily able to read all of this, log in, and get the information that we needed for our clients. As a part of our ERP package, we have started to add some more AI insights as well. So our ERP package, it has inventory, resource, and asset management and tracking, vehicle mileage, shipping manifests, safety certificates, HR management. So modules that are really more industrial based. In terms of trying to reduce some of our client waste, what we've been trying to do a lot more is study the patterns on when our clients and vendor managed inventory are going to need more supply. A lot of the supply that they are managing does have expiration dates on it, especially around PPE. It has to be recertified at a certain point in time. It can only have a certain shelf-life. It can only have a certain shelf life. So we're really starting to dig into the data so we can offer our clients insights on when they need to reorder and resupply their goods as well. We've been working with the Saskatchewan Polytechnic in the city here with one of their student groups to expand our service offerings. We've been working on an HR component so we can onboard employees automatically. One of the requirements from our clients was they wanted some more advanced facial recognition. Some of the problems that they've had are employees aren't updating their photos when they need to. They can't see if it's actually the right person on the photo. They wear sunglasses, they're frowning, too much light, too little light. So to remedy that, we've integrated with Microsoft. They have a platform called Cognitive Services, and it's really simple to do. All we need to do is we upload a photo to their platform, and they send a bunch of insights back. And based off of these insights, we can tell if our clients' staff are actually meeting the criteria required for the photo. So some of our clients, for example, said they can't be smiling in the photo. It has to be just a regular, straight-on professional shot. So if someone tries to upload a photo and they're smiling, we say, hey, sorry, you can't smile in this photo. You got to make sure it meets the criteria. A little funny, interesting bit here. When I'm smiling, it says that I'm 32. When I'm frowning, it says that I'm 37. So for any of you that are interested in shaving a few years off your age, smile goes a long way. So one of our other clients, a company called NSC Minerals, so they do a lot of logistics of road salt and potash. So their whole system was very manual beforehand. They had paper map, potash, and road salt from them. So it's a pretty complicated supply chain that they deal with, and there was a lot of manual steps and manual data entry required. So over the number of years, we've been really doing an A to Z solution for NSC Minerals based off of Levis Prism and integrating with some AI platforms. So for them, we created a mobile app so that their customers can log in and order whatever they need. Then we've integrated with General Electric on their shipping software, which kicks back the load information to our platform, which results in their customers getting their road salt and potash. So this system worked pretty good. It has a bidding platform as well, so people can, so that the carriers can bid on the loads, whether it's by semi or by rail car. But the problem that they started to experience with it was, as you see, we have warehouses full of potash and road salt, but their clients weren't actually updating their inventory levels. So, for example, if they had the city of Calgary as one of their clients, and the city of Calgary ran out of road salt, they would call NSC and say, hey, it's snowing, we really need road salt, and we need it here yesterday. And of course, that is a bit of a logistical nightmare. So NSC Minerals came to us and said, hey, is there a way that we can automate this? What's the technology looking like these days? So at first we looked at scales, but scales were very cost prohibitive. They could be $40,000 to $100,000 per warehouse. We looked at infrared technology, but it wasn't working too good for our needs either. But then we came across this artificial intelligence library called EveryPoint. And EveryPoint had another platform based on top of it called Stockpile Reports. And it's a more complicated computer vision program. And what it would do is it monitors the pile of the road salt or potash in real time, and it tells us what the volume of it is. So in our system, when the inventory hits a certain threshold, now we can do these orders automatically so that the clients don't have to worry about waiting until it snows until they put in the orders if they forget. So the ordering system was fine and dandy, but the missing point in all of this was really the artificial intelligence and machine learning component and the automation that it provided in order to keep a live feed on these piles. So a lot of
Jared,
sorry. Yeah.
Sorry to interrupt, but just in the interest of time, we might have to wrap up. Was there any one more slide or any last point that you'd like to throw out there just before we'll have to move on?
For sure. This was actually the last slide. So
perfect.
And it was really just for people that are interested in artificial intelligence and machine learning and how to apply it to your business processes. I talked to a lot of people that get very excited about it, but their IT infrastructure isn't really at the point where they can do it yet. So really, if you're interested in what artificial intelligence and machine learning can do for your organization, you really have to make sure that your IT backbone is in place and you do have apps and automation that your users are already engaging with in order to get this sort of data. So I'll leave it at that. That's just one of the common questions that comes up. So yeah, that's about all it. Thank you, everyone, and sorry about the technical glitches at the start there.
No worries, no worries. It's bound to happen with all of the video conferencing and everything. That was really great. And it was really insightful. And you actually touched on a couple of, that last slide was one of the questions that I already had written down. And I like that you touched on, when people think of machine learning and artificial intelligence, it seems like a very grand, big thing. And you had mentioned like chatbots and answering services and stuff, which seem small, but they help out so much. So that was really awesome. Thank you very much, Jared.
Thank you, Nolan.
All right. So next up, we have Matthew Smith. He is a technology sales engineer for MachineX, specializing in robotics and optical sorting, covering North America and part of Europe. We got some intercontinental business going on. Matthew has over 25 years of business experience in the area of sales and application with a strong focus on customer satisfaction. Most recently, he spent the last year working as a sales engineer for Schmid Biomass Boilers in Canada. So thank you very much for joining us, Matthew, and I'll let you just take it away. Welcome.
Yeah, thanks very much for having me. Perfect. No, perfect. So I'll go straight into the presentation then. So I work for MachineX. We specialize in MRFs, so the complete start to finish of a recycling facility, from conveyors, sorting of the paper and everything, and also then specializing in robots and optics. So how they really work then. Most of the robots that they have are basically, they've got eyes. So it's a camera that will actually see exactly what a person would see. We're looking at the material stream that's going down the belt and looking at it to see if there's fiber, if there's different types of plastics and aluminium cans. And based on that information that it's actually gathering, this information is then passed on to the brains of the robot system. And this will then tell the robot itself exactly what it's actually looking at. So we teach the robot to analyze this data, and based on this data that it's actually using, it can then give a criteria and place the objects that are going along the belt into different groups, whether it's PET, HDPE, PP, all the different fractions that we've actually taught the robot to foresee then. So this is the last slide is actually showing you exactly what the robot is seeing on the belt. It's identifying the object, and based on that, then it's classifying the object to say this is an HDPE or PET. So when you've got a robot, there's got different ways of picking that material from the belt. You can either do it through a suction cup. So we induce a vacuum through a hose, and we suck up the objects through a suction cup. and place it into the bin, or we use a gripper style arm, normally used in construction and demolition. Another one that we always forget about is air nozzles. If you've got an optical sorting machine, so an air nozzle is the same kind of thing, but you're ejecting the fraction of material that you want to sort into different bins using air. So this is another way to purify the stream, and it's a form of hands that an AI unit will use. So this is something of a picture of what we use at Machinix, is the suction style gripper to extract the material from the belt. So one that we look at is actually a fast picker. This is one that we normally implement then if we're doing a high pick rate on the sorting belt. So this is one that we use at Machinix. Another one is the gantry style, and this is normally used for construction and demolition. So you're picking up larger pieces of material and then placing them on the belt, and it has the gripper type arm or hands. The other one is Cobot. This is one that is very similar to what our arms are, and you've got a great control of flexibility to pick up the different materials. Another one is just the pick and place SCARA system. This is normally used in an application then for assembly and moving one part from one place to another. Then you've also got the 6-axis machine as well. That's also used a lot in manufacturing. And the final one is then what we discussed before is the optics as well. So this is using sort of nozzle bar to eject the material. And where would you use a sort of a robot within the MRF or the recycling centers? The first one would be on a container line. So you're using it as a QC, so the quality control. So the material's already flown down the recycling center, and you're coming to the end now that you're wanting to really sort out to purify the stream. You use the robot then to extract the fraction that you don't want to have in that belt. So if you're purifying a HDPE line, you can program the robot then to remove all other fractions that you don't want. Or you could use it positively, and this way, if you want to pick out a certain material to have a pure stream of that material, then you'll use a robot to actually go for that material. So you could have a PET, HDPE, or aluminium, and that would also help to get a pure stream depending on the market. And if you've got something in place that says that the material that you need has to be 100% pure, then you'll use a positive sort of the material. We can also do fiber lines. So if you're wanting to purify also the fiber, you could do that, but based on the speed and the spread of the material on the fiber lines, it's normally quite difficult to put a robot on there. And then the other one that I talked about before was construction and demolition, and then also organics, is to try and remove certain organics then from the stream that you can go off to compost. So when you're looking at a robot and the placement of the robot in the facility of the MRF, then you've got to look at many different things to take into consideration. It's not a case of just taking a robot and putting it in and switching it on. You have to make sure that the whole thing is powered up. It's connected to the internet so you can get updates. You need to make sure that the material that's going down the belt is spread out, access to it, because you need to do also maintenance. So it's quite complex when it comes to putting in a robot within a MRF, but it's doable, and you have great benefits from actually doing this within the MRF. So looking at the main components of a Samurai robot that we produce at Machinix, it's basically a drop-and-play system. Then there's lighting, cameras, there's a conveyor belt that's there. We're making sure that it's hooked up then for pneumatics. because we eject the material over the bins, the electrical paneling, making sure that we have full access to the machine so you can carry out maintenance. So these are the main components within the system. Another difficulty when it comes to looking at a MRF then is also the film that's going down the line. So you're getting plastic bags or sort of types of wrapping. What is unique in regard to Machinix Robots, then we can have a customized vacuum system. So we can have one that's just the integrated standard one that we're picking 20 to 30 bags going down the line before you have to empty it out, or we've got a standalone external vacuum system, and that will capture a lot of the film, which then is not really required in your stream. So if you're picking PET, you don't want to have the plastic film in that because it downgrades the material itself. So you're getting actually a lower price for your material than if you would do if that was not in there. So this is quite unique, and it's something that's not really the best to have in a MRF. It's something that a lot of MRFs struggle with, is with the film. So what you need to do about you need to optimize the use of a particular robot within in the MRF. Then it's making sure that the speed of materials going down the belt correctly. That if you're picking the material from the belt, it's not only going for one type of material. It's making sure that you can maximize the amount of picks that robot can do. So presently, we're picking about 70 picks per minute, which is sort of a lot higher than a human would do. A human is picking on average 35 to 40 picks per minute. So when you have that, and there's no tea breaks or no time to be sick, so it sees a place now in the recycling centers that a robot really benefits to when you install one, because you're going to maximize the amount of material that you're recovering in order to recycle that. I've just got a little video that you can actually see. So hopefully you got an understanding of the Samurai robot in operation there, picking different types of material within the MRF. just to purify the stream. And it also, we can have the robot also work in tandem with a person as well. So you can have the person before or after the robot, and you can also reprogram the robot if the market changes, that you have to have a different type of material that you would like the robot to pick. We can then change the program and have the robot pick another material. We can give it different priorities to pick one material over another, first and second and third. So the options are there to really benefit from a robot within the recycling of your within the MRFs. So thank you very much, and we'll pass it back over.
Wow, thank you very much, Matthew. That was great. As someone who has spent over a decade sorting recycling by hand, my arms thank you. And I could just watch those sorting videos all day. It's so awesome to see that happening in real time. So thank you very much, Matthew.
Thank you very much.
Next up, we have Sam Dietrich. He is the co-founder of Prairie Robotics, Inc., a company specializing in robotics and machine learning solutions. He previously completed his Bachelor of Applied Sciences and University of Regina, at the University of Regina, sorry, with a major in industrial systems engineering and a double minor in electronics and software systems engineering. During his university career, Sam represented the University of Regina in numerous exchanges, including a 9-week research internship at the India Institute of Technology, Kanpur, working in the Center for Mechatronics, which I'm sure is just as awesome as that sounds. In addition to working for Prairie Robotics, he's also been employed by Vivo Application Studios, Dot Technology Corp, and Offstreet Technology Corp. How you found the time for all of those jobs with all of that schooling is beyond me. That is amazing. So welcome, Sam.
Thank you. Thank you for that introduction, and thanks for the Sask Waste Reduction Council for this conference. As previously said, I'm Sam Dietrich of Prairie Robotics, here to talk to you today about site scale. So I'm going to start off by talking about machine learning, big data, and its relevance to Saskatchewan and beyond. So as we previously learned, machine learning is the study of computer algorithms that improve automatically through experience. So how does this actually look? The first step involves collecting data of what you're interested in, annotating or labeling that data, in this case an apple and an orange, and then feeding it into a computer or a machine learning model. At which point you're capable of showing a computer an apple or an orange and having it automatically label it for you. In this case, even labeling the type, be it Granny Smith. And while being able to automatically identify an apple or an orange doesn't seem immediately useful, everyone here has already been interacting with machine learning through Siri, Netflix, or Google, be it through Netflix's recommendations or Google's search results. What are the applications to the waste industry? So as Matthew previously showed, MachineX is doing this for sorting. Right here, we're looking at a data set that we've done to automatically identify the type of waste being received at a landfill. This is another video showing a real-time identification of both a vehicle type and the type of waste being received. And although you can actually see inside the vehicle, the system has learned that every time this Loris disposal truck is coming, it's bringing garbage, and it's therefore automatically assuming that it does have garbage. So big data, this is the analysis of data to discover hidden trends, patterns, or behaviors. McDonald's, funny enough, has actually become a prolific user of this recently with their digital kiosks in store, looking at customer demographics, ordering through their mobile app, and for forecasting staffing requirements. And again, what are the applications to the waste industry? Well, here we can see total Saskatchewan waste over the past 10 years broken down by residential and non-residential, and also per capita. in addition to the provincial goals for 2030 and 2040. Zooming in on Regina, we can look at total waste over the same time period and waste per capita, again broken down by residential and non-residential, in addition to the amount of waste being diverted. We can further analyze the curbside waste. We can look at the amount of waste being diverted through Regina's Blue Cart recycling program. And what's very interesting is we can look at the curbside waste composition and then use that to understand the potential and actual diversion. So in Regina, about 51% of our curbside waste are organics, 11% are recyclables. So when you look at this and you compare the potential for what we're currently diverting, you can see there is a lot of opportunity for increasing recycling and organics collection. What's really exciting about a system like this, in addition, you can look at where this waste is coming from, be it residential and self-haul or non-residential. So what's really exciting about a system like this is we can look at comparing two jurisdictions, be it Regina and Saskatoon, to look at the difference between total waste and waste per capita for the two cities. And in the sake of time, I'm going to keep moving on with the presentation. So in summary for big data and machine learning, big data is looking at historical trends, data analysis, whereas machine learning is looking at automatic identification. Big data on the left here requires a human to understand it, while machine learning makes automatic decisions. So how does site scale fit into all of this? Well, at Prairie Robotics, we've developed site scale landfill management technology that consists of an operator application to capture incoming waste and to sync this data in real time. On-site cameras to capture the vehicle and the waste, providing feedback in an auditable system. Machine learning to identify the waste type, vehicle amount, and waste amount. And then automatic reports generated like the data visualizations we previously saw for key performance indicators for billing, accessible to municipal, regional, and provincial stakeholders. So why is this relevant? Well, Saskatchewan alone has 203 landfills, 207 transfer stations, all used by 1.1 million people who produce just shy of 1 million tons of garbage annually. So from a data perspective alone, the amount of information in the system is significant. Well, when we look at Canada, the order of complexity just increases with significantly more landfills, significantly more people, and even more garbage being produced annually. So that's our very quick presentation on machine learning, big data in the waste industry and how site scale ties into it. I'm Sam Dietrich of Prairie Robotics. Thank you for your time.
Wow, that is awesome. I love numbers, and so seeing all that data analysis was that's incredible. And there's so many insights that you could get out of that you normally probably wouldn't be able to see in older models without machine learning. And you've successfully been able to compare apples and oranges. So that's great. So thank you guys very much, all three of you guys, for presenting. There's just a ton of information in there, and for sharing your expertise and kind of opening the window. As I had said before, after Jared's presentation, that when people think of AI and machine learning, and even just saying robot, you think these big, grand, crazy ideas, when really you can apply them to so many different aspects of the industry, especially just in waste, between the sorting and analyzing the data, and even just reducing your workload on your human staff so that they're able to free up their time for more in-depth projects, thinking, all that kind of stuff. So I know I loved all of that. Thank you guys very much. I don't see a whole lot of questions in the chat. If anybody in the audience would like to ask a question, or they would like to just have even a small discussion, we got about 7 or so minutes. Then just throw it into the chat. If you'd like to ask live, I think we can do that. If Meg is able to turn on your webcam or your microphone.
Yep, I can do that.
Awesome. So I had a question with for Matthew. So with all of those different techniques and all of the different applications that each individual robot and the way that they pick out, could you see a MRF that is fully automated using only robotic solutions and machine learning and artificial intelligence as a recycling, well, like a MRF, but just fully automated? Stuff is dumped in one end, it's sorted, and it goes out the other end?
Yeah, no, I can see that coming along now. The only thing that, I mean, the human involvement today is not that great compared to what it used to be. There's going to be a lot of AI being put into different types of equipment to have a better sorting. It's probably going to go into optics. It's going to go into the robots. So at the end of it, there's going to be very little human interface with the material going into the stream. You'll just get it dumped on the floor, and it will be fed into the MRF. So there's different types of the MRF. So you've got the single stream, and that's where we see a lot of technology being invested going forward.
That's awesome. Very, very cool. And yeah, like I said, having done human sorting of those materials for a very long time, I'm very excited for solutions like that.
I do have a question.
Yeah.
I think it was Jared that had an image of the sorting bin that they have in the Vancouver airport. I was just wondering how common those are and what like how accurate they are, and like what.
So, I'm not sure how common they are. Like, I don't think I've seen them around Saskatoon, to tell you the truth. This on the same slide, like the one at the airport, I think is a bit more of a one-off. But on the other slide, there was that other company called Binny, and they have theirs was a bit better, I thought, because you didn't even have to hold it up to the camera; you just put it in. And that was a commercially viable product, or that's like something that they have out in the wild right now. Mm-hmm. What kind of distribution they have, I'm not sure, but like anyone can order one of those for their to have on premise if they desire.
Oh, go ahead, Tim.
I was going to say a follow-up to that is the Oscar sorting platform. The reason that they have the human sorting it, they use the example of a paper coffee cup. So you have the cup, you have the coaster, and you have the lid. Each of three has to go into a separate bin. So I'm not sure how that automated sorting works, where you have items that actually consist of other items on it. So I think that's the reason they went with their approach.
That makes sense. Do any of you know how accurate they are, like what the success rate is for the products being sorted properly?
I could not tell you.
There's just a comment in the chat saying that they are super expensive, like Krista. Sorry, Nolan, that's your job.
No worries. I seen that. The expense, yeah, I kind of figured that would be the case. My thing was, having worked at Sarcan, like I know how much space that stuff can take up. Mm. So I'd be curious to find what their solution is for the management of when it's full, how full it can get, like how much it can store, because it's a very, or in the pictures anyway, it seems like a very small area that it's taking up. I'm sure there's some sort of storage for it, but it's very, very neat.
Mm-hmm.
Yeah, and I'm sure it is really expensive now. The first few generations of technology usually is pretty expensive because these companies need to recoup their R&D costs. And as you start to do different models and iterations, and you find ways to bring down the costs as well. But at this point in time, yeah, they probably are a little cost prohibitive, but give it a little bit of time, because that technology, although it's a little more cutting edge now, in 5 years from now is going to be a lot more derivative, and you'll be able to mass produce it a lot easier.
Mm-hmm.
Yeah. One other question, I guess, would be, how easily are these systems scaled up? So if you have a small industry or a small company organization, and then you start to balloon out, you're growing. Are you going to have to keep on searching new alternatives, or can the original smaller system just scale out and you can just kind of add on to it?
So I guess from our standpoint, like the consultants that we are working on for any of the solutions we're putting into our products, the challenges we take are pretty narrow. And talking to the people that we've been working with, if the problem is derivative of that, then it's usually pretty easy to take our model and make it work on similar problems without reinventing the wheel. But if we have a problem in industry A and then we have a problem in industry B, we just can't like copy and paste the solution over there. So at least like from what we're doing, they don't necessarily like scale too well, and as in they start doing a lot of things extra that they weren't intended to do. Does that answer your question? Like
yeah, no, totally.
Okay.
Awesome, thank you. I guess it would be safe to say that none of you guys are as scared of AI as Elon Musk is.
Well, truthfully, I mean, despite that, I said it seems like it's more focused on specific problems. I think it is a matter of time before these things do become more generalized, and that's where it'll be scaling up really quickly, is when it isn't focusing on specific little problems, but like a lot of the AI research that's being done now is trying to teach AI to generalize itself, right? Now, okay. I haven't really seen anything that's commercially available where it does a good job of that. Maybe someone else here has, but I think that's more where Elon Musk is saying once it gets to the point where it can start generalizing itself and figuring out solutions on its own, then that's where there's going to be a lot of disruption, right? So we aren't there yet. It is probably coming, but it's not really in scope for the kind of problems that we're taking on right now.
Okay, cool.
But with our luck, we're going to be old people anyways by the time that'll happen. So unfortunately, everyone in this room is still going to have to bust their butts off until retirement if you were looking for an easy way out.
Well, all right. Fine. No, that's all right. I already apologized to my electronics if like I drop my phone, just in case they've already started and they know that we're on to them. I think that's kind of all that I had. It doesn't look like there's any questions in the chat, but once again, thank you guys very much for taking the time to share all of this with us, and maybe hopefully open the door for more opportunities of robotics, machine learning, AI in our industries. And once again, just a quick shout out to Mterra Environmental for sponsoring this session. We can't have any of this without our sponsors, and so we thank them very, very much. And with that, I think we're good.
Mm-hmm.